So today we're going to be talking about polynomials. So to begin, what is a polynomial? Well, I wrote the words that we're going to be dealing with, including polynomial, on this sheet of paper. And notice that I highlighted the part of the word poly in red because we kind of know what poly means. Think of a polygon. A polygon is a many-sided figure. The poly means many sides or just many. So when we see polynomial, we're thinking many something. Well, what we're actually talking about is many, and then the nomial part refers to terms. So polynomial just means many terms. So I'm going to write that down. Many terms. And what we mean by terms is expressions with a number and a variable. So term, we're talking about numbers, and that's being multiplied or divided by variables. And when we say variables, we're talking about a letter such as x, y, t, n, anything like that. Alright, now let's move on to monomial. Mono, you can think of monochromatic, which is a painting done in all one hue. For example, it could be done in different shades of blue, but it's still one color, blue. So monomial is only one term. So an example of that would be 5x or 3x over 2 or 2x squared over 5. Or it could be something as simple as a number such as 6. All of these examples are monomials, one term. Now binomial. Binomial, you can think of bilingual, meaning you can speak two languages. So binomial would be two terms. And examples of those could include 3x plus 4 or 5x over 2 minus 4. Notice we have an x, and then we have another term, the 4. When we say many terms, we're talking about the exponents. So x cubed, x squared, x, a number. Now the only thing you have to remember with polynomials is you can't have negative exponents. So I'm going to write a non-example down. Non-example. Non-example would be x to the negative 5. You do not want to see that. You don't want to see a negative in the exponent. Nor do you ever want to see an x in the denominator. Because when there's an x in the denominator, that is simply saying a negative exponent. So these non-examples, we don't want to talk about them. We're only talking about when we have positive exponents. Notice right here we have 3x plus 4. The x has a positive 1 exponent, and actually by that 4 we have x to the 0 exponent. That's what makes it invisible, x to the 0. So they all have an x somewhere in there, but they're kind of hidden. And lastly, trinomial. Trinomial, think of triathlon, 3 events, so that would be 3 terms. Examples of those, let's do 4.7x to the third minus 2x plus 4. So we have one term with the x to the third, we have another term with the x, and our last term with the 4. Alright, so here you have all your polynomials and your specific types. Now let's look at a few examples and identify how many terms it is, and let's see if it has a special name. Also, let's say if it is a polynomial or not, or if it has one of those negatives. That way we can say it's not a polynomial. So let's begin with a few examples, such as x squared minus 10. Oops, let's redo that. X squared minus x to the 10th plus x to the 24. So let's set up a little table here. Number of terms. Is it a polynomial? And name if it has one. Okay. So the number of terms. Let's count and see how many different exponents we have. We have x squared, which is 1, so put a tally. Negative x to the 10th, that's a different exponent, so another tally. And x to the 24th, that's a different exponent. All these are different, so that means there's 3 different terms. So I'm going to add up my tallies. So 3 terms. Now, is it a polynomial? Well, ask ourselves, do we see negatives in the exponents, or do we see dividing by x? Nope, they're all positive exponents, and there's no division by x. So polynomial, yeah. And name, does it have a special name? In other words, does it have 1, 2, or 3 terms? Those are our only special names. So it has 1, 2, 3. So that makes it a trinomial. Okay? So now let's take a look at negative 4x to the 6th minus 2x to the negative 1 plus 2. Okay? So let's count our terms. We have 1 with the x to the 6th. We have 2 with x to the negative 1. And we have a last one with just our number 2. So total, that's another 3 terms. Now ask ourselves, is it a polynomial? Well, does it have negatives in the exponents, or does it have division by x? Nope, no division by x, no negatives. Oh, but right here, there's a negative in the exponent. So that means it's not a polynomial. So no. And that means there is no special name. So, not a polynomial. We're not dealing with it in this section. Let's try another example. 5x minus 3. Now, this one you have to expand. What I mean by expand is distribute the 5 to the x and to the negative 3. So that would equal 5x minus 15. I simply multiplied 5 by x and 5 by negative 3 to equal this. Now, let's count the number of terms. We have 5x and we have negative 15. So that's 2 terms. Now, is it a polynomial? That means negatives in the exponents or divide by x. Nope, all positive exponents. So, yes. And does it have a special name? Well, it only has 2 terms, so that means it's a binomial. And how about one more? Let's do 7 4x squared minus 3x plus 1. Alright, so let's count our terms. We have 1 right here with the x squared in the denominator. We have 1 right here with the 3x, and we also have just our plain old number 1. So that makes it 3 terms. And is it a polynomial? So negative is in the exponents, or x is in the denominator. Well, right away we see that this x right here, it's in the denominator. So that means, nope, it's not a polynomial. That means, since it's not a polynomial, it doesn't have a name. That's all there is to it. So again, we have polynomial, which means many terms. To be a polynomial, it cannot have a negative exponent or an x in the denominator. A monomial is 1 term, binomial 2 terms, trinomial 3 terms.